Welcome to the second video in the overview of our migration project methodology. In the previous video, we delved into the concept of workload and its definition, which is closely tied to the business objectives of the client. In this current video, we will shift our focus to crafting a future architectural blueprint tailored to the client's business goals. Let's revisit the 5 scenarios from the preceding video and outline the future state architecture for each of them. In the first scenario, the client wants to transition from their Microsoft package to an open-source database on AWS Cloud, such as PostgreSQL or MySQL, while retaining the HR Manager C# application on premises. Here is the workload we've defined for the current architecture. Now, let's outline the state of each component within the workload for the future architecture. We'll begin with the SQL Server database. The customer wishes to transition this to an open-source database on the AWS Cloud. After weighing the pros and cons of available choices, the customer opted for Amazon RDS for PostgreSQL. We've adapted the SQL queries of the HR Manager C# application and reconfigured it to communicate with this migrated database. A word on the notation: a solid color fill in a component signifies a complete replacement, while outlining denotes specific code modifications. For the ETL/SSIS, we recreate its functionality using AWS Glue. Reaching an agreement with the customer on both the current and future state architectures is the foundational step. Only after this alignment can we determine which system artifacts to collect and analyze, enabling us to craft a detailed project estimate and execution plan. To execute each transition, it's imperative to define a toolkit. In our case, as we migrate to the AWS Cloud, we use AWS SCT for converting applications and database schemas. For data migration to the cloud, our tool of choice is AWS DMS. A comprehensive transformation table, similar to the one shown, serves as a blueprint. Now on to the second example, where they're exploring the idea of swapping their core data Oracle database for an open-source AWS Cloud alternative. To test this, they've proposed a proof of concept on AWS, encompassing the Oracle database, its maintenance tools, and both the manufacturer C++ and CRM client bridge Java applications. Let's define a future architecture for this business goal. We found out that the customer is primarily inclined towards Amazon Aurora PostgreSQL as the target database. To run manufacturer C++ and CRM client bridge Java applications in the AWS Cloud, we propose to take advantage of Amazon AppStream 2.0. The essence of this service is to launch a desktop application in the cloud and interact with it through a browser. As for database maintenance components, we replace Oracle Recovery Manager, which makes scheduled backups, with Amazon Aurora Backup Service. The database performance monitoring implemented in the current architecture with SQL scripts, we recreate with Amazon CloudWatch and with Amazon Aurora Performance Insights. The customer wants to test the capabilities of both of these services and then make a choice. This is the future architecture aligned with the customer's business goal in this scenario. The detailed transformation table for this scenario looks like this. Moving on to the third scenario, let's imagine that this proof of concept project has been successful and the customer has decided to perform the actual migration of the Oracle database to Amazon Aurora PostgreSQL. Based on the validated POC strategy, we migrate the core data Oracle database to Amazon Aurora PostgreSQL. We also move both the manufacturer C++ and CRM client bridge Java applications to Amazon AppStream 2.0. As the CRM client bridge Java application moves to the cloud, we ensure its reintegration with the DL Boost Salesforce application. We replace Oracle Recovery Manager with Amazon Aurora Backup Service. For database performance monitoring, the client opted for both services trialed in the POC: Amazon Aurora Performance Insights for in-depth database load analysis and Amazon CloudWatch to monitor and notify on the health of the database, and what's more, the 2 AppStream 2.0 applications. The HR Manager C# application remains on premises, but we update it to connect to the core data PostgreSQL database. As for the data integrator ETL/SSIS process, we retain SSIS but adjust its code to integrate with the core data PostgreSQL database. The transformation table for this scenario is detailed as follows. In the fourth scenario, the client is considering a partial shift while not fully breaking from their Oracle data warehouse. They're interested in migrating a segment of their data warehouse to AWS platforms like Redshift or Data Lake, but plan to keep the Data Integrator ETL SSIS, Insight Analyzer Java application, and Visual Reports on premises. Bringing the client's goal to life, we migrate the designated subset to Amazon Redshift, selected as the target after consulting with the customer. We integrate ETL SSIS with Amazon Redshift, and it continues to transmit data to the Oracle data warehouse. While the Insight Analyzer Java application and Oracle Visual Reports remain in the on-premises customer data center, we adjust them to ensure compatibility with the data subset migrated to Amazon Redshift. Here is the detailed table showcasing the transformation for this scenario. In the last scenario, the client aims to fully transition from the Oracle warehouse to AWS platforms, moving the Insight Analyzer Java application to AWS, while redeveloping the Data Integrator ETL SSIS and Visual Reports using AWS services. In this case, the customer also chooses Amazon Redshift to migrate their entire Oracle data warehouse. We also migrate the Insight Analyzer Java application to Amazon AppStream 2.0. We replace the ETL SSIS functionality with AWS Glue. For the Visual Reports, which were built on the Oracle Business Intelligence Enterprise Edition tool, we recreate them in Amazon QuickSight. For this specific scenario, here's the detailed transformation table. In this video, we detailed the scenarios to design the client's future state architecture, clarifying the transformations from their current one. In our next video, we'll focus on collecting and analyzing migration project artifacts. This analysis will help us estimate project phases, leading to a well-rounded project plan for presenting to the client. Thanks for watching, and see you in the next video.